Okay, today we're going to be talking about operations with radical expressions. So, unlike radicals, is something like root 3 plus root 2. We can't add those. They're not the same. Versus if I had something like 7 root 3 plus 9 root 3, we could add those together. Now, what you do when you add those, you add the coefficients that are out front, which is 16, and then the root 3, look at it like it's just a variable. We don't change our variable. When we add a 7x plus a 9x, we don't do anything to the variable. That just gets left as 16x. So we only add like radicals. That's what we're going to be doing here, and we're going to be multiplying radicals. Okay, so simplify this. So notice how all the radicals are the same. So I can just do 6 plus 2, which is 8, minus 5, which is 3 root 5. Okay, our next example. So these are like radicals. So I have 7 minus 6, so that's just a root 2. And then we add those, minus 4 root 11. And that's our answer. Now those were the easy versions. You know I'm not going to give you an easy version. This one's more like an example I'm going to give you. I'm going to give you one where you have to do some math. We have to see how we can get these to be like radicals. So 27 can break down into 9 times 3. Again, you want to try and break these down so that they are the largest perfect square. 3 has no more perfect squares. 9's the largest thing. 8 root 12. Okay, so 12, well, that's 4 times 3. 75 is 25 times 3. So the 9 breaks out and becomes a 3 outside. Eventually I'm going to multiply it to the 6. The 8 breaks out and becomes the 4 breaks out and becomes a 2 outside. 25 breaks out and becomes a 5 outside. So 18 plus 16 plus 10, well, that's going to be 44 root 3. And you notice each one of those radicals, it was kind of nice. They broke down into the same radical. Okay, now simplifying these. I feel like we've kind of done a little bit of this already. Multiply the like numbers together. So that's 8. Then underneath the radical, I'm going to have 3 times 6. But that 6 can break down into 3 times 2. I have 2 3s. Those can break out of our house, become a 3 outside. 8 times 3 is 24. Ooh, this is a fun one. Oh, I didn't know how much I would like this example. Okay, so what we're going to do is we're going to take and we're going to distribute this to each term. So I'm going to have 4 root 2 times by 3 root 2. Then I'm going to take and distribute it to this next term, plus 4 root 2 times by 2 root 6. Okay, 4 times 3, 12. If the radicals you can multiply together. So what I can do is I can multiply the 2 and the 3 together and get a 6. 4 times 2 is 8. 2 and a root 6, that can be multiplied together to be a 12. So I multiply the 2 times the 6 because they're under the radicals and being multiplied. So I can combine those. There's no perfect squares in 6 that can be broken out of that radical. But 12 can be written as root 4 times 3. 4 can come out, become a 2 out in front of my radical. I'm going to continue it up here. I guess I could have written it down there. So that's what we get for that. And I can't, now under addition, I can't combine those radicals because the radicals are not the same thing. It's like having an x and an x squared. Okay. Find the area of a rectangle in simplest radical form with a width of that much and a length of that much. So, area is length times width. So I have to now write that out. My length is 5 root 3 plus 7 root 5. My width is 4 root 6 minus 2 root 10. So now it's a matter of foiling. Okay, it's just a bunch of foiling now. Multiply first terms together. So 5 root 3 times by 4 root 6. First terms. Outer terms. Plus 5 root 3 times by a negative 2 root 10. Inner terms together. And then our last terms together. Seven root 5, and then I change my sign to a minus because that 2 root 10 is a negative. So now it's just a matter of just doing a whole bunch of simplifying. 5 times 4, well that's 20 root 18. Minus 5 times 2, well that's 10 root 30. 7 times 4 is 28 root 30. 7 times 2 is 14 root 50. Now we want to see if I could pull out any perfect squares. 18 can become a 9 times a 2. 10 root 30. 6 times 5, 15, 2. No. But what I can do is I can combine these 2 root 30 terms to get me an 18 root 30. 50 can become a 25 times by a 2. 9 can come out and become a 3 out front. $25 can become a 5 out front. So I have 28 times 3. Well, that's 84 root 2 minus 18 root 30 minus 70. I don't know why I wrote root 5 there. So now I have 84 minus 70 that I can simplify these two radicals. I can combine those and get 14 root 2 minus 18 root 30. Okay? And that is our video on simplifying radicals. What was it? We were adding and subtracting like radicals. That's what we were doing.